Section 12.5, Simplifying Complex Fractions. This note sheet is in your Canvas shell in the modules for module week 2A. We're going to look at 3 types of problems in section 12.5. 2 of those are going to be complex fractions. The 3rd type is going to be a complex algebraic expressions. When you see a complex fraction, it's fractions in fractions. So lots of fractions, and they're a little bit intimidating. We'll do some examples in just a little bit. The first method for simplifying complex fractions is to simplify the numerator so that it's a single rational expression, and simplify the denominator so that it's a single rational expression, and then divide the numerator by the denominator and reduce to lowest terms. That method's going to involve using one of the symbols that we probably don't use very much, haven't used much since grade school. That's the division symbol that has the dot and then a horizontal line and a dot underneath it. The second method for simplifying complex fractions is going to require us to find our least common multiple for all of the denominators that are in both the numerator and the denominator. And then we're going to multiply the numerator and denominator times that least common multiple. Then when we simplify the numerator and denominator, the fraction should reduce to lowest terms fairly easily. When we're looking at simplifying complex algebraic expressions, it could be a combination of our first and our second method. But a complex algebraic expression is going to involve rational expressions with more than one operation. So we are going to be adding, subtracting, multiplying, dividing, a combination of different mathematical operations. That's what makes a complex algebraic expression. We need to remember our order of operations. Parentheses or grouping symbols first, exponents second, multiplication and division from left to right, addition and subtraction from left to right. Once we have a simplified expression, we will know that because we will have a single fraction or one reduced rational expression. That's how we know that we've simplified that complex algebraic expression. And really that's true for all of these. When we get done simplifying our complex fractions, we should end up with one rational expression or one fraction in the end of the problem. Example number 1, 2x to the third over y to the fourth all over 5x to the fourth over 3y to the third. I'm going to replace this large division bar with that old-fashioned division symbol, rewriting this problem as 2x to the third over y to the fourth divided by 5x to the fourth over 3y to the third. Remember, I do not like to divide fractions. I would rather multiply fractions. So I'm going to turn this into a multiplication problem. And we'll have 2x to the third over y to the fourth times the reciprocal, which would be 3y to the third over 5x to the fourth. Now I multiply across the top. 2 times 3 is 6, x cubed, y cubed. Multiply across the denominator, 5x to the fourth, y to the fourth. Now I need to look at what can be reduced. 6 over 5 is already in lowest terms. I have 3 x's in the numerator, 4 in the denominator, so I divide out all of the ones in the numerator. I'm left with just the 1 in the denominator. I have 3 y's in the numerator, 4 in the denominator, so I divide out all the ones in my numerator. I'm left with 1 in my denominator. My answer then becomes 6 over 5xy. Example number 2 is 5x squared over 3y to the third over 3x to the fourth over 2y. I will rewrite this as 5x squared over 3y to the third divided by 3x to the fourth over 2y. Rewriting this as a multiplication problem, I'm erasing here, and I erased the wrong thing. Rewriting it as a multiplication problem, I have 5x squared over 3y to the third times 2y over 3x to the fourth, which is the reciprocal. Multiplying across the numerator gives me 10x squared y. Multiplying across denominators gives me 9x to the fourth, y to the third. 10 over 9 is already reduced. I have 2x's in the numerator, 4 in the denominator. So I divide out all the ones in my numerator, and I'm left with x squared in the denominator. I have 1y in my numerator, 3 in my denominator. I divide out all of them in my numerator. I'm left with y squared in my denominator. So my solution is 10 over 9x squared y squared. Example number 3. We have x plus 5 over 5x divided by 5x minus 4 over 2x squared. Same process. I will rewrite this as x plus 5 over 5x divided by 5x minus 4 over 2x squared. Rewrite it as a multiplication problem. X plus 5 over 5x times 2x squared over 5x minus 4. Multiplying numerator times numerator, I have 2x squared times the quantity x plus 5. Multiplying my denominators, I have 5x times the quantity 5x minus 4. I look at what I can reduce. 2 over 5 is as simple as it gets. I have an x squared in my numerator and x in my denominator. The x in my denominator divides out, and it leaves me with 1x in my numerator. I have x plus 5 in my numerator, 5x minus 4 in my denominator. Those are not like terms, so I cannot divide anything out there. My final answer is 2x times the quantity x plus 5 in my numerator divided by 5 times the quantity 5x minus 4 in my denominator. And you do not have to multiply those out. You can leave them just like that. Example number 4 is 2 plus 6 over x all over 2 minus 5 over x squared. This is the situation where I'm going to need to determine what my least common multiple is for both of the numerator and the denominator and what their fractions are. I have an x in my numerator as a fraction. I have x squared in my denominator, so my lowest common multiple is x squared. What I'm going to do now is multiply x squared times that numerator, which is 2 plus 6 over x, and I'm going to multiply x squared times my denominator, which is 2 minus 5 over x squared. If I have x squared over x squared, that's essentially 1, so I'm not changing what the fraction is, the value. I'm just doing this to help eliminate some of those fractions that I'm dealing with, because I do not want more than one fraction to have my complex fraction simplified. Distributing in my numerator, x squared times 2x is 2x squared. X squared times 6 over x is plus 6x. In my denominator, when I distribute, x squared times 2 is 2x squared. X squared times 5 over x squared is minus 5. I will factor out the 2 in my numerator and the x. Because it's a common factor, I have 2x times the quantity x plus 3 in my numerator. I have 2x squared minus 5 in my denominator. And I look to see if anything can be simplified, and it cannot. So that is my solution. 2x times the quantity x plus 3 over 2x squared minus 5. Example number 5 has 5 over x squared minus 10 over x cubed all over 7 over x squared minus 28 over x to the fourth. My least common multiple for all of these, it's going to be the biggest one. So I have an x squared, x cubed, another x squared, x to the fourth. So my lowest common multiple is x to the fourth. So I am going to multiply x to the fourth times my numerator, which is 5 over x squared, minus 10 over x to the third, over x to the fourth times that denominator, which was 7 over x squared, minus 28 over x to the fourth. When I distribute, x to the fourth times 5 over x squared leaves me with 5x squared. X to the fourth times negative 10 over x to the third gives me minus 10x. In my denominator, x to the fourth times 7 over x squared is 7x squared. X to the fourth times a negative 28 over x to the fourth is negative 28. It looks like I have common factors in both my numerator and my denominator. I can take a 5x out of my numerator, which leaves me with x minus 2. I can take a 7 out of my denominator, which leaves me with x squared minus 4. And x squared minus 4 is actually a difference of squares, so I can keep factoring. My numerator stays 5x times x minus 2. My denominator becomes 7 times x minus 2 times x plus 2. Now I can simplify. The x minus 2 in my numerator and denominator will divide out, leaving me with 5x in my numerator and 7 times the quantity x plus 2 in my denominator. Example number 6, we have 1 over x minus 2 over x squared all over 6 over x minus 24 over x cubed. My lowest common multiple is the smallest one of all of those, or largest one of all of those. I have an x squared, another x to the third, so my lowest common multiple is x to the third. I'm going to multiply x to the third times my numerator, which is 1 over x minus 2 over x squared, and take x to the third times my denominator, which is 6 over x minus 24 over x to the third. When I distribute in my numerator, I end up with x cubed times 1 over x being x squared. X cubed minus 2 over x squared ends up giving me negative 2x. In my denominator, x cubed times 6 over x is 6x squared. X cubed times negative 24 over x cubed is negative 24. Once again, greatest common factor in my numerator is an x, leaving me with x minus 2. Greatest common factor in my denominator is 6, leaving me with x squared minus 4. I have a difference of squares again in my denominator, so my numerator is x times x minus 2. My denominator becomes 6 times x minus 2 times x plus 2. I'm able to reduce the x minus 2 in my numerator and denominator, leaving me with x over 6 times x plus 2. And that is my solution. Example number 7, we have x plus 3 over 6x all over 3x minus 5 over 4x squared. I will rewrite this as x plus 3 over 6x divided by 3x minus 5 over 4x squared. I will rewrite this as a multiplication problem, giving me x plus 3 over 6x times 4x squared over 3x minus 5. When I multiply my numerators together, I end up with 4x squared times x plus 3. In the denominator, I have 6x times 3x minus 5. Now I start reducing. 2 goes into 4 2 times. It goes into 6 3. I have x squared in my numerator, x in my denominator. It leaves me with x in my numerator. So my numerator becomes 2x times x plus 3. And my denominator becomes 3 times 3x minus 5. And we can box that in. That's as low as it'll go. Example number 8. This is the third type. So this is a rational expression where I have subtraction and division, because I have 7 over x minus 6 minus 2 over 3x divided by x minus 6 over 9x. We need to remember we're going to use order of operations. There are no grouping symbols, no parentheses. There are no exponents. The next thing we look at is multiplication and division from left to right. So I'm actually going to do this division first right here. I'm going to do the 2 over 3x divided by x minus 6 over 9x. So as I rewrite this problem, I'm going to leave 7 over x minus 6 at the beginning, minus, and I'm going to look at 2 over 3x, and I'm going to go ahead and turn that into a multiplication problem, times the reciprocal, which is 9x over x minus 6. I need to do this part first. I'm putting in this grouping symbol just so you all recognize that, because I need to do the multiplication first. So I'm leaving 7 over x minus 6, keeping my minus sign here, and I'm going to do the math. 2 times 9x is 18x. In my denominator, I have 3x times x minus 6. I'm going to go ahead and reduce what I can in this piece. This becomes 6. So I have 7 over x minus 6 minus 6 over x minus 6. This is nice. Did you notice how the denominator is now the same after all of that fun math that we just did? Seven minus 6 is 1. So our solution is 1 over x minus 6. Order of operations. That's what we did here, ladies and gentlemen. So I focused on the 2 over 3x divided by x minus 6 over 9x. I went ahead and turned that into a multiplication problem because it's what I like to do anyway. I don't like to divide. So 2 over 3x times 9x over x minus 6. I simplified that. And then, luckily, I was left with a common denominator, and all I had to do was take 7 minus 6. Here's example number 9. This is another one where we have addition and multiplication, so we have more than one operation. Now, what's different about this one is I actually have a grouping symbol here because I have parentheses around the first two pieces. So let me read the problem. Parentheses, 3 over x plus 5 over x minus 8, close your parentheses off, times 4x minus 32 over x. Or the quantity 3 plus x, or the quantity 3 over x plus 5 over x minus 8 times 4x minus 32 over x. So in this particular problem, the very first thing that I would want to do would be what was in the parentheses. 3 over x plus 5 over x minus 8. So I need to know what's my least common denominator for those two fractions. Think back to what we've done in those previous sections. It's x times x minus 8. That's our least common denominator. So I'm going to rewrite that fraction so that both denominators are x times x minus 8. In my numerator on the first fraction, I have 3 times x minus 8 because that's the piece that's missing from my original denominator. My second fraction, I'm going to have 5 times x. And like previously, I'm going to carry that 4x minus 32 over x through the problem until I have what's in the parentheses simplified. So I'm ready to write this as one big fraction over here. X times x minus 8 is my denominator. I'm going to distribute. 3 times x is 3x. 3 times negative 8 is negative 24 plus 5x. Keep that 4x minus 32 over x. 3x plus 5x is 8x minus 24 over x times x minus 8. I'm multiplying that times 4x minus 32 over x. I can take out a greatest common factor between 8x and 24. If I take out an 8, I'm left with x minus 3 over x times x minus 8. I can take a 4 as a greatest common factor between 4x and negative 32, which leaves me with x minus 8. And there's an x. Now, this is a problem where it's going to be easier if I simplify diagonally. I have x minus 8 in this denominator and x minus 8 in that numerator. And that's all I can simplify. So 8 times 4 is 32 times x minus 3 in my numerator. And x times x is x squared in my denominator. And that's as far as it'll go. And that's the last example that I'm going to do from this section. Hopefully you're finding these useful. And I look forward to the next video.